And it looks like we're live. Noah, Cameron, take it away.
My name's Noah.
Hi, I'm Cameron.
We are the founders of Lucky Bird Inc. And we are developing tools to help city planners make smarter decisions around real-time dynamic scheduling of public transportation. So the impact of what we're doing is that it means that city planners will be able to use the resources that they have when creating bus routes, creating schedules, and they'll be able to optimize it by doing analysis in real time. We see this not only impacting the cities by being able to schedule in a smarter way, but we see that everyone who uses the bus or trains in cities every day will have trains and buses that are less crowded, that are more consistent, and that are on routes which get them to where they're going faster. Cam?
Yeah, so we thought about this, how we were going to build this. We talked to a couple people who work for the SF MTA, about what they need and what they have problems with. And they gather millions of data points every day. They have GPS systems on every bus, and they track every passenger that gets on, and to a certain extent, everyone who gets off, so they can know the load on all these buses. But they have no real tools to analyze all this data that they're gathering. So we actually were able to get a sample of their data for about a week, and it was millions and millions of lines, and just one a few giant CSV files. So we built this framework. I used Clojure, which is kind of language really designed from the ground up to be able to do stuff in parallel. And so I use that to build these tools that can actually take all this data and use as much computing power as is available to it, and actually analyze it and present it in some meaningful way, so the SF MTA can make some decisions and actually learn something from all this data they're gathering.
So specifically, when we talked to the city, they had two big problems that they're trying to solve now, and that we see will also be problems in the future. And like Cam said, we built it using Clojure as a framework, so that when we actually do have gigabit, and when we do have networks that have no limits whatsoever, this can be a framework where millions and millions of data points can be plugged in, and it can be running it all in real time. And but anyway, let me get back. So the two problems that the faces is they need to know where buses are slowing down along their routes and why. They also want to make sure that buses are providing service to the right places within the actual city. So the way that we were going about solving these answers is that we're looking at real-time data of the buses along its routes, and we're pinpointing where on the route it's getting slowed down. And the SF MTA has this real-time data, but they're not doing any of the analysis to really get down to where this is happening along the routes, and that's something that we've been able to do. The other thing is that they let us have access to their passenger data from 1 week, which was, like Cam said, tens of millions of lines that we were analyzing. So we were able to basically map out and chart out where people were actually using the buses to get around. And we showed what we built to the SF MTA, and they're really happy because they have the power to move extra buses around as if it's a chessboard. So if there's an emergency situation, if there's local events, they're able to actually respond to what the needs are to the city. And right now, I want to show you a screen capture of what we built. And Cam, if you want to talk about the text at all. Okay. Here we go. So, yeah.
Yeah, so I built this pretty, I guess, what they wanted, I guess the most useful thing for Muni from what we talked to them about would be sort of like a dashboard where they can actually visualize all this data they're gathering. So this is what I built. Analyzes all their data, and shows them kind of heads up. These things that they would have been able to figure out all along, but there's just so much data and no real framework in place to process it. Before this, they really couldn't have just got these simple statistics the way they can now. And you can see from the data we have, you can see when the buses are late. What the passenger counts are. You can see they kind of like gradually fill up and things like that. And show one of the stops.
Sorry, so passenger count means the current carrying load of the bus?
Right now it's the average number of passengers at each of the stops on the bus at that time. So.
Okay. And
we also have the info for the actual loads of these buses, so we can say whether it's at an acceptable weight or if it's not. And we're seeing that there's lots of places where it's not.
Yeah, and you can dig in really deep to any of these numbers and see everything in detail. So it's like a really, I guess, simple way to visualize a pretty complicated set of data. And it's all open source, so anyone can plug in new data to it, look at things in a new way.
Are they so how are they going to take that visualization tool and make it and like decide to put a bus on another route or something, or what's the thinking at this point?
Yeah.
Well, at this point, I think this tool really just gives a broad overview of their routes, so they can take a look and find out, hey, no one uses this stop, or it's always really crowded right here.
Mm-hmm.
To do more of the real-time stuff, we're going to have to keep on adding to this framework, but we built it in such a way that it really encourages adding new features to it, bringing in more data. It's extensible, so it really has the potential to do all this analysis that can change the way we make these decisions.
And really, the way that we see this fitting into a gigabit network where there's no limits is that actually on the US Ignite website, they're looking at an example of where basically traffic signals will adjust to the actual flow of vehicles in the city. So this means that it will be doing analysis on thousands of factors which sensors around the city are picking up and tracking. So we're building the analysis framework to take all of this information, millions and millions and millions of pieces, and then turn that into something that can be done actionable in real time to change the way that transit is operating. So we kind of feel like we're at the tip of a really big iceberg, but that will be a reality in every city in the next 15 and 20 years.
Yeah, so okay, so we're almost out of time, but let me jump ahead to what do you think the next steps are as far as taking this to like the SFMTA, and what are you asking for in support this round? Right.
So like we said, we were able to get 1 week's worth of data, which was useful, but the next step is really working with the MTA to be getting like data in real time every day, so we can provide them with really big answers. The other thing that we're building about what we're building is that it's completely open sourced. So this code can be built upon, it can be used by anyone in the future who wants to work on this problem, and we're also hoping to build it so it can be expanded out to any transit system in any city in the entire world. So right now this is SF only, but we're going to make it open source so that it can solve problems for anyone. Next steps for what we need is we need money so that we can hire another dev, even if for 2 months, but so that we can really bring it to that open source part. And also we've been doing this bootstrapped the entire time, so we'd really like to get some money to pay ourselves too, which is why for the next 2 months we're asking for $30K so we can bring it to that next step and so that we can build this tool out so it can be open source for the entire world. And yeah, we really are passionate about this problem, and we see it helping people not only now, but in 15 and in 20 years.
Cool. Well, hey, I'm going to cut it here.
Any other questions?
Thanks, guys. That was really cool.
Okay.
I mean,